Until now, we have talked about several concrete models under the framework of Bayesian deep learning, and these models can all be represented using a generalized graphical model. And the Bayesian treatment of these models can be performed by natural parameter networks, or NPN. And interestingly, natural parameter network, it's useful not only for Bayesian deep learning model, it can also be used for as a building blocks for a lot of other models like in domain adaptation or deep Bayesian networks. And so now I will talk about more recent work on using these natural parameter networks as building blocks with some applications on healthcare. Recall that in our previous healthcare examples, we say that the deep component will handle the symptoms and high dimensional signals, physiological signals, and the graphical component will handle the diagnosis. But what if for different patients, we actually have different tasks? For example, for patient 1, we want to predict variable A given variable 1 given variable 2. But for patient B, we actually want to predict variable 2 given variable 1. How do we do this? One idea is that we can use a large perception NPN to handle or model the physiological signals, which is high dimensional. And then we use several small reasoning NPNs to model the variables of interest. And basically, each of these reasoning NPN will handle one particular conditional dependency. For example, here, this will effectively form a network of subnetworks. We can see that for each, for the edge of different color, it actually represents a different NPN. We have a large perception NPN and we have several small reasoning NPN. And the learning and inference can actually be performed via feed-forward and backprop across all these subnetworks. As a simple example, imagine we want to predict variable 1 given variable 2 and x. We only need to first feed-forward from x to compute the embedding z, and then we feed-forward with one pass to compute the prior of x1, and then we do multiple passes of backprop to update or infer v1, so that we can get a maximum a posterior estimate of v1.